Hello, Tualatin. It's Sam here from the Tualatin Public Library, and I'm here to share with you a new program that we're doing that we're calling Kitchen Science. It's basically two of my favorite things wrapped up into one program, my kitchen and science. It's all right there in the name, right? Kitchen science. So we will take basic things you can find in your own kitchen and we will do some super fun science experiments. So let's get started. All right, today's experiment will be pretty simple. We're going to start off simple with just three things. Okay, you're going to need to find yourself a glass. You're going to need to find yourself a vat of vinegar. You're going to need about a cup, so you will need a good bit of vinegar for this, but vinegar is not very expensive. And you're going to need one egg. All right, so once you've found all those items, and feel free to pause if you need to go gather some things, what I want you to do is think about what might happen if you put an egg in a vat of vinegar. What do you think? What's going to happen to that egg as it sits in that vinegar? Let's see. So what you can do right now is you can posit a hypothesis. A hypothesis is just a big, long word for a guess. It's a scientific guess based on, hopefully, some facts and some science that you might know as to what might happen in a science experiment. So a hypothesis, let's see. If we put our egg in vinegar, maybe it'll explode. I love exploding stuff. That would be super fun. If we put an egg in vinegar, maybe the vinegar will cook the egg. If we put an egg in vinegar, maybe it will make an egg that tastes terrible like vinegar. You think about it and you come up with your own hypothesis with what you think might happen to that egg as it sits in that vinegar. All right, let's do it. All right, do you have your hypothesis, your guess as to what might happen? Okay, let's put it to the test. Here's our glass. Here's the part where you have to be careful. You don't want to just drop your egg in from super high or you're going to have a super big mess in the bottom of that glass. So slide that egg in there so it doesn't break. As I said, you're going to need about a cup of vinegar. See if that works. You just need to cover the egg entirely. So we're going to pour our vinegar over our egg. Yep, that is enough. And then let's hold that up to the camera and see if you can see what's happening. As that vinegar kind of settles its way around that egg, if you look really closely, you can see the egg is covered in what? Bubbles. There's bubbles all over that thing. Now, what is happening there? Why are bubbles forming all around the shell of that egg? That was not part of my hypothesis. So once again, bubbles everywhere. And that's how the experiment begins. Let's see what's going to happen. All right, it's time for some science. It's time for some science. It's time for some science today. Let's do some science. Once again, we have an egg here covered in bubbles. Why? Let me tell you why. The vinegar is water mixed with acetic acid. It's mostly water. It's only 4% acetic acid typically because full power acetic acid would not be useful for household purposes. It'd be too powerful. But so you got acetic acid in the vinegar, and it's having a chemical reaction with the calcium carbonate, which is what the eggshell is made out of. And that chemical reaction produces calcium acetate, water, and carbon dioxide. Guess what's inside of all of those glorious bubbles? Carbon dioxide. So that chemical reaction creates all the bubbles on the outside of the eggshell. But that doesn't solve the hypothesis. It doesn't answer our question. What's going to happen to that egg aside from being covered in bubbles? You want to find out? Let's find out. All right, we've talked about some science. Now it's time for us to have some results. And the fun part of a science experiment is that once you've done your testing and you've done the experiment, you get to come up with some results and then compare them to your hypothesis. So my hypothesis was that the egg would explode when it was covered in vinegar. Let's see if that's true. This is what, after 24 hours, actually more like 30 hours, sitting in the vinegar, my egg looks like. It did not explode. My hypothesis was wrong. And a lot of science is about creating a hypothesis, finding out it's not correct, and then going back and making another hypothesis. So let's go ahead and dig this puppy out of the vinegar real quick. I'm going to pull it on out so we can look and see what did happen. It didn't explode. That's probably nice because that would have been a mess to clean up, and nobody likes an eggy mess. But let's see what it did happen. Okay. Can you see? This is an egg, the way it started. This is the egg after sitting for 30 hours in vinegar. Do you see some differences? The color is different, right? This is a much lighter colored egg. It's no longer brown. Another difference? It's bigger. Through the process of osmosis, some of the water from the vinegar has made it inside of the egg and expanded its size. Wild. But here's the best part. This is super fun. Can you normally do this with an egg? Isn't that the coolest? It's super springy because of the reaction of the vinegar with the calcium carbonate, of the acetic acid with the calcium carbonate. It has broken down the solid surface of the shell and turned it into a squishy, soft shell. So, no longer do you have a hard egg that when it falls, it's going to break. You have a soft, squishy, springy egg that is actually see-through. So I'm going to do a few more little clips and I'm going to show you a few things about this newly transformed egg. Some of the wonders of vinegar and some of the wonders of science. All right, let me show you what's probably the coolest thing about this egg right here. Check it out. It bounces. So... oh, check it out. I got a mess to clean up now. It bounces, but the thing about this is that it will not bounce from a super high height. So you can see, once I went up to about 6 or 7 inches, it was not bounceable anymore. And now I have a mess on my kitchen counter that I am going to have to clean up. So don't bounce it from too high, but from 3 or 4 inches, you can get that puppy to bounce and you can create an egg with just some vinegar that is almost as bouncy as a bouncy ball. How cool is that? All right. Let me show you one other thing from this experiment that just exploded. So maybe my hypothesis was correct. This is what the eggshell looks like now. It's like stretchy. It's like a rubber band. Isn't that cool? And this is all from the reaction of the calcium carbonate and the acetic acid. It broke down that hard shell. It broke down the calcium in the shell. And it turned it into a semi-permeable membrane. Awesome, right? So go forth, get an egg, get some vinegar, do some science for yourself, and see how much fun kitchen science can be. I'll see you in a few weeks. Bye. All right, now, there's a lot of ways that you can extend this experiment. So I was using a brown egg, and it took me 30 hours. Now, you might not get the same results with a different egg. Let's say you use a white egg. It might take longer. It might not take quite as long. So it might take you 3 days to get the results that I got. Now, one place that I read said that after 24 hours, you might need to change the vinegar. So you may need to use another cup of vinegar if it still seems like a solid egg thing after 24 hours. Pour off all the old vinegar, put new vinegar on, and then give it another 2 days and see if that works. Now, there's other things you could try too. I used white vinegar, maybe cider vinegar. What about red wine vinegar? There's so many different vinegars out there. I kind of want to find out how different vinegars react with different eggs. You could make a whole journal of different kinds of eggs and different ways those eggs react with different vinegars. So if you dig this experiment, there's a lot of different ways that you could try to change it and tweak it and see if you can get different results. All right, have fun experimenting.